Today we're going to knock out polynomial and rational inequalities. We're going to put all this factoring that we've been doing to use. So the procedure for this is going to be, first of all, write the inequality in standard form. Okay? Remember, what I mean by that is get 0 on a side by itself. Okay, next up, identify the critical numbers. This is a new term for a lot of you. Critical numbers is going to be anything that makes the equation equal to 0. Okay, makes, I'll say equation, even though we're doing inequality today, makes equation equal to 0. You'll kind of see what we mean by that when we do our first example together. I want to draw a number line with these critical numbers on it. So whatever I find on 2, I want to put it just on a simple one-dimensional number line. Right? And then from there, we got to test the numbers on number 4. And then finally, we're going to start something called interval notation that's going to be sticking around for quite a while with us. So I'd like to work part B first. I think that's a better first example, and I'll let you guys work A. So first thing I notice is that it's not in standard form. I don't have 0 on a side by itself. Well, I can still subtract 15 from both sides, and that's going to give me p squared minus 2p minus 15. Oh, not equals 0. They were doing less than 0 in this case. So now what I'm going to do is just factor this. A lot of these will factor. I think we're going to run into 1 tonight and 1 in a minute that does not factor. So this will just factor into p minus 5, p plus 3 equals 0. So I get p equals 5, p equals negative 3. Nothing new so far. Okay, here comes the new part. That 5 and negative 3, instead of those being my answers, I am going to call those critical numbers. And I'm going to put them on my number line, negative 3 and 5. And so what that does, it breaks up my number line into 3 different regions right here. And so to figure out what my actual answer is going to be, since it's not going to be negative 3 and 5 anymore in the inequalities, I have to plug in numbers in these 3 regions to see if it gives me a correct statement. So what I mean by that is I have to plug in a number between negative infinity and negative 3. Any number will work. I'm going to plug in, I'm going to say negative 4. So when I plug in negative 4, I'm going to come back to this original right here. I'm going to plug in negative 4 in for both of these p's. So I get negative 4 squared minus 2 times negative 4. It's less than 15. So that's 16 plus 8 is less than 15. 24 is less than 15. No, that is not true. So what I'm going to do is I'm going to put a big X on there. That is not going to be part of my answer. I'm going to do the same thing between negative 3 and positive 5. I love the number 0. I love plugging in 0. If I plug 0 back into this, I get 0 squared minus 2 times 0 is less than 15. So 0 is less than 15. Is that true? Yeah, that's true. So I'm going to do, I make a happy face in that spot. I like that region in between 3 and 5. Anything negative 3 and 5. Anything I would have plugged in there would have given me a true statement. Finally, I'm going to check this third region. Anything between 5 and infinity, I can plug in. I like to stay close to the boundary because that will keep my numbers small. So again, I'm going to plug this 6 back in for these p's. So that gives me 36. Let's see, minus 2 times 6 is minus 12 is less than 15. 24 is less than 15. No, that's not true. 24 isn't less than 15. So that's my number line. Okay, I think in algebra 1, what we did was we shaded this region. We said, yeah, that region right there works. However, today I want to introduce something called interval notation. Interval notation, what I'm going to do is I'm going to write the region that the numbers work from negative 3 to 5. I put negative 3, comma 5. And since it's less than, what I'm going to do is I put parentheses around it to show that negative 3 and 5 are not part of my answer. If I was to actually plug in negative 3 and 5, remember that would be critical numbers. That's what makes the equation equal to 0. I don't want it equal. I want it strictly less than. We'll go over that again in a minute if we need to. I know that's going to be new and a little bit confusing. But this answer right here, negative 3 to 5, is what I am looking for. I'm going to let you work part A. Take it as far as you can. We might come in and do the graphing part together. Okay, so go ahead and pause the video. Notice I already have it factored for you. So all you have to do, you can go straight to plotting numbers on your number line. Okay, you should have got that the -4 to 2 region worked and the 2 to infinity region also worked. Okay, now my answer is going to be a little bit different this time. For what we're doing for right now, let's just write down both of these regions where they worked. Okay, now I accidentally put a parenthesis there. Let me erase that real quick. The -4 to 2, what's going to happen on it? Since it's or equal to this time, that means if I plug in -4 or +2 in for these x's, it will actually come out to equal 0, which is okay with this problem because I have the greater than or equal to. So to show that it's okay, instead of using parentheses like we did on the last one, I'm going to use brackets. And in math, we have a special way of saying or. Okay, instead of saying, when we say or, we put a U right there. It means unioned with. I can pick anything between -4 and 2, anything from 2 to infinity. Well, infinity is not a number, it's an idea. I can't ever touch infinity, so actually plugging in infinity into this equation would not work. Infinity and negative infinity always get a parenthesis whenever we're writing our answer. So your parentheses and your brackets will mix and match on these. Let's try one more of these. Let's try a word problem. I picked one that I didn't think was going to come out very nice. Radiant Farms, they sell canned unicorn meat. For each can, the marketing, research, and financial departments estimate that at a price of P dollars per unit, the weekly cost C and revenue will be given by the equations. Uh-oh, I left a little R off there. This should be an R, not a P. Given by these equations. I want to find where, I'm just going to find where it makes a profit at. Okay, we can tackle the loss. Well, in order to make a profit, from what I know about business, I'm pretty sure you have to have more money coming in than you have going out. In terms of revenue and cost, I have to have more revenue than I do cost. So my revenue has to be greater than cost. Plugging this in, I get 7p minus p squared has to be greater than my cost. This is just a direct substitution step right here. Now this one's nowhere close to being already set up into standard form. I'm going to be picky about this. Remember, I said in an earlier video, I like it so that my p squared term is positive. It's negative right now. So what I'm going to do is I'm going to subtract 7p off both sides and add p squared to both sides. That's going to leave me with a 0 over here for my standard form. I'm going to rearrange this just a bit. Now I have my standard form. And all I got to do is think of 2 factors of 13 that add up to give me -8. Yeah, there's not any that do. So I got to go to my fallback. I've got to go to my completing the square. So I'm just going to work this out here over on the side. I'm going to make a little hole right here to complete the square. So remember, to complete the square, I'm going to take half of 8, well, that's 4, and then square it. I do 16. Whatever I do on one side, I have to do on the other. That makes the left side factor nicely into p minus 4 and p minus 4. Take the square root of both sides. The square root of 3 doesn't break up. It's just going to stay a nice square root of 3. Add 4 to both sides. I get these critical numbers that look a little bit messier this time, but that's all right. We're going to work with them. And those are the 2 numbers that go on my number line. Now, my general rule with this is if we're working with a word problem here, 4 plus the square root of 3 doesn't really carry very far into my answer. So I'm going to go ahead and do 4 minus the square root of 3 in my calculator. And I've got the first number on my number line. I'm going to put it way down here. it's going to be $2.27. Like I said, we call that a critical number for a reason, because at that point, I'm either going to start making a profit or I'm going to start losing money. Okay. On the other side, 4 plus the square root of 3 gives me $5.73. Again, something important is going to happen right there. So what I'm going to do is I'm going to plug in my numbers and see what happens. Oh, I love 0 down here, so I'm going to plug in 0. Let's see, between $2.27 and $5.73. I don't know, I'll just choose $3. And then bigger than $5.73, I'm going to choose $6. Okay. Now, it's probably going to be best to plug this all the way back into this original right here. Okay, so plugging in 0, let's see, that's going to give me 0 on the left side, and it gives me 13 on the right side. Well, that's not true. It's not bigger than 13. Okay. Plugging in 3. Again, I'm plugging it in next to where this red arrow is. That gives me 21 minus 9. 21 minus 9 is 12. If I plug in 3 on the right side, it gives me 10. 12 is greater than 10. I like that region. If I plug in 6, for time's sake, if I plug in 6, it's not going to work. Just to let you know. So I'm going to be making a profit whenever I sell a unicorn between $2.27 and $5.72. You don't really have to do anything for the loss. We've already worked it out. For the loss, it's going to be where these X's are. Because I'm not making money with unicorn meat. I'm losing money. Now, I'm probably not going to give the unicorn meat away. So I need to go ahead and start at 0 instead of negative infinity. So I actually have a price on it and stay within the domain of the problem. So I'm going to have a loss if I put the price of the unicorn meat in one of those two number regions. You have one like this in your homework. If I remember correctly, it will factor. You'll have another one that doesn't factor, but it'll be a little bit more straightforward than this one. Okay. Rational functions. Rational functions are going to work very similarly. So I'm only going to work a couple of these to kind of get the idea across. So with a rational function, the only thing we need to change is our idea for a critical number. Okay, idea of a critical number, remember, is what made the equation equal to 0. I'm going to change it for a rational function. It's going to be whatever makes either the top equal to 0 or what makes the bottom equal to 0. Okay, so I am going to go ahead and work just part B right here. And if it can be what makes the top or bottom equal to 0, that means that 1 is a critical number. And plus or minus 3 is a critical number. So there's a difference on this one. Let's say we got -3, +1, and +3. We have 4 regions to check on this. There's not a set number of regions on these to check. Most of them will be 3 or 4, but if you do get more than 3 or more than 4, we just have to check them all. Okay. So I'm gonna plot my numbers. Let's say I'd like to, like I said, I like to stay close. -4. Ooh, 0's in this one. I'm definitely gonna use that. 2 is about the only number I can use in that one. And then 4 right there. Now I'm going to get fractions on these, okay? And again, I'm plugging it back into this original box right here. So 1 minus -4, that's a 5. -4 squared is 16. 16 minus 9 is 7. That's less than 0. Oh wait, that's greater than 0. I want less than 0. So this region does not work for me. Ooh, we get to plug in my favorite 0 right here, all right? By the way, I was looking for it to be less than 0, but it wasn't. So I plug in 0 on this. Well, 1 minus 0 is 1. If I plug in 0 on the bottom right there, I get -9. -1/9 is less than or equal to 0? Oh, yes, it is. Right. I like that region. Plugging in 2. 1 minus 2 there on top is -1. Plugging in 2 on bottom. 4 minus 9 is -5. Well, that ends up equaling +1/5. That's not greater than or equal to 0. So I don't want that region. Finally plugging in 4. 1 minus 4, this one up here is -3. And down bottom, 16 minus 9. 16 minus 9, 7. That is less than or equal to 0 because I got something negative. Oops, I got a happy face. So my regions where this works are between -3 and +1, and between 3 and +infinity. All right, I'm already going to throw another wrench into your parentheses and brackets. Okay, you're looking at this, you're saying, okay, well, it's less than or equal to. We should use brackets like we did on the first slide, on example 1, where it was or equal to. Well, that's fine, but remember, I'm not able to touch infinity. And if that's my rule, that I'm not able to touch numbers, and that's where I have to put parentheses, then I also need to keep in mind that I'm dealing with a fraction right here, and I am not allowed to have 0 down here. It makes it so it's undefined. So I'm not allowed to touch -3 or 3 either. So I'm really mixing this up this time because I am allowed to touch 1. That just makes it equal to 0. I like equal to 0. Everywhere else, it was either infinity or undefined, and I do not want to touch if it's infinity or undefined. Okay, I'm going to work one of these, and then I'm going to leave the other one to you to work. I'm going to start off with C over here. I'm going to work C, and then I'm going to pause the video and let you work D. Remember my very first rule, it has to be in that standard form. And I'm just going to call standard form whenever it has 0 on one side. All the cross multiplication stuff, multiplying to get rid of fractions, does not work on this. If I do that, I'm going to be eliminating solutions. That only works for when we have an equality. Okay. So since that doesn't work on this, what I'm going to have to do is I'm going to have to actually just subtract off one side and just make it so it's 0 on the other. Now what I'm trying to do on this, I'm trying to add a fraction and subtract a fraction and then a whole number. Okay. Back in the day, I always learned that in order to do that, I had to have common denominators. So the smallest thing that x minus 1 and 1 both go into is x minus 1. And you can just get that from multiplying your two denominators together. That will always give you your common denominator. Well, I'm going to work a problem up here just as a parallel problem. Let me change it to a minus. So it's like this one. -1/4. Okay. I know my common denominator between these two is 20. Because I'm taking 5 times 4, and that gives me 20. That's the exact same thing I do with my denominators right here. But my numerators don't stay the same. Because if I multiply the bottom by 4 on this left fraction, I've got to multiply the top by 4 as well. And if I multiply this bottom by 5, I have to multiply the top by 5. I want to use that same idea. To come from x minus 1 down to x minus 1. Yeah, I didn't multiply anything. I multiplied by 1. So that doesn't change the top. However, on this right side, you can see that I multiplied the bottom by x minus 1. So I need to multiply the top by x minus 1 as well. All that's going to be equal to 0. I get this cleaned up, and you're going to see that it works a lot like the last problem. I think you'll even have less critical numbers, perhaps. So here we go. I'm just going to clean this up. I got x plus 3 minus 3x plus 3 over x minus 1. Okay, I'm going to have to move over a column here. So I've got x minus 3x, that's negative 2x. 3 plus 3 is 6 over x minus 1. All that has to be less than 0. Getting my critical numbers now. Anything that makes the top or bottom equal to 0. I'm going to be a little shorter this time. Let's see. Negative 2x plus 6 equals 0. So that would be at 3. So I'm going to put a 3 here and a 1 there. So I just have 3 regions to check on this. So between negative infinity and 1, I'm going to plug in 0. I'm going to bring it all the way back right here to the beginning, just in case I goofed up my math somewhere, or I can't read my writing or something like that. So if I plug 0 into this, I get 3 over negative 1. That's negative 3. Oh, -3, that's less than 3. So I like this region. It's a good one. I think I'll choose 2 between 1 and 3. That seems to be a pretty good number between them. So if I plug 2 into this original, let's say it gives me a 5 on top, and it gives me a 1 on bottom. I get 5 is less than 3. No, that's not right. 5 is not less than 3. Switch colors so you can kind of follow me here. Between 3 and infinity, again, I like to butt up right up next to it and choose 4. That gives me a 7 on top. That gives me a 3 on bottom. Yeah, is less than 3. Ooh, careful with that. 7/3. That's like 2 1/3. 2 1/3 is less than 3? Yeah, it sure is. Put a circle right there, or a happy face. You can breathe a sigh of relief because it is strictly less than. I don't have to worry about any brackets on this. If you don't see the or equal to, that means your parentheses through and through, no matter what the denominator is, no matter where the infinities are, and that would be my answer. I'm going to pause the video. This part D is a tougher one, but I'm going to go ahead and work it out so you can follow along with it if you want to. You can work it out ahead of me while the video is paused if you want to as well. Oh, doozy of a problem with those critical numbers being so close. You had to plug in some decimals or some fractions in between. But this is what I got for my happy faces. All right. So it's strictly greater than again. So I can just roll through with just parentheses on this. And that'd be my answer. Good luck on this. Give it a shot. Like I said, it's just the factoring we've been doing. All we're doing new is taking those answers that we get whenever we factor, throw them on a number line, and then check your answer.